How do irrational numbers fit into real numbers? Have you ever wondered how certain numbers fit into the vast world of mathematics? Today, we will explore the fascinating relationship between irrational numbers and real numbers. Let's break it down step by step. Real numbers are all the numbers you can find on the number line. They consist of two main groups: rational numbers and irrational numbers. Rational numbers can be expressed as fractions, like 1/2 or -3. On the other hand, irrational numbers cannot be written as simple fractions. This means every irrational number is indeed a real number, but not every real number is irrational. To get a clearer picture, let's define these groups. Real numbers include both rational and irrational numbers. Rational numbers can be written as a fraction where both the top and bottom are whole numbers, and the bottom is not zero. For example, 3/4 and 0.75 are rational. Now, what about irrational numbers? These numbers have decimal expansions that go on forever without repeating. A classic example is pi, which starts as 3.1 for 159 and continues infinitely. Other examples include the square root of 2 and Euler's number. So, how do these irrational numbers fit into the real number system? The real number line is continuous, meaning it includes all points corresponding to both rational and irrational numbers. Irrational numbers fill in the gaps between rational numbers. For instance, between any two rational numbers, there is at least one irrational number. This characteristic is essential for the completeness of the real number system. Let's look at some properties of irrational numbers. When you add a rational number to an irrational number, the result is always an irrational number. Similarly, if you multiply an irrational number by any non-zero rational number, the outcome remains irrational. Although irrational numbers cannot be simplified into fractions, they can be approximated by rational numbers to a high degree of accuracy. Irrational numbers are not just theoretical, they have practical applications too. They often appear in geometry. For example, the diagonal length of a square with sides of 1 unit is the square root of 2. Additionally, constants like pi and Euler's number are vital in science and engineering. In summary, irrational numbers play a significant role in the real number system. They expand our understanding of numbers beyond just fractions and whole numbers. Recognizing how irrational numbers fit into real numbers helps learners grasp the full scope of mathematics, especially in algebra and beyond.